Hello and welcome back. We've spent some time looking at whether or not our trig functions are going to be positive or negative depending on where what angle we're looking at. But I also want to spend some time looking at the ranges of trig functions, meaning what are all the possible values that you can get if you plug an angle into one of our trig functions. We've seen that you can get positive and negative values, but exactly which positive and negative values. So the one thing that I really want to point out here is the fact that R is going to be the hypotenuse of a right triangle. So whenever you have an angle here, we can form a right triangle like so. And the distance up from the x-axis to our point is going to be y, and our distance across is going to be x. So this is a right triangle. R is the hypotenuse, and it's going to be at least as big as x and y. This doesn't really matter where the angle is located. So even if we had an angle that was, say, all the way like this, and here is our point x, y, we'll see that, okay, x is going to be negative now, and y is also going to be negative. So the distance from here to here, distance is still positive, so this is going to be the absolute value of x, and this is going to be the absolute value of y, and the length of this line there is going to be r again. And again, this is a right triangle, this is the hypotenuse, so r is going to be bigger than x, meaning the absolute value of x, and r is going to be bigger than y, meaning the absolute value of y. And in fact, it will be greater than or equal to both of these. When can it be equal to? Let me draw another picture. If we had an angle that was already a right angle, so let's say that this is our x, y up here. Well, we know what x is, for instance. X is just going to be 0 because we're not over to the left or right. And r is the distance from this point to the origin. So in this case, r is in fact going to be equal to y, and x is just 0. So the take-home message here is that r has to be bigger than x or y, or at least as big as, so it's greater than or equal to x and y. So what does this mean? So let's look at what this implies for our trig functions. Since r is going to be at least as big as y, this means that this fraction here, I'll always have a smaller number on top than on bottom. And if I take a number and I divide it by a bigger number, that means that this can never be bigger than 1. Y could be negative, but again, in absolute value, this guy can never be smaller than -1. So the sign of an angle is always going to be between 1 and -1. It could be as big as 1, it could be equal to 1, it could be equal to -1, but it's always trapped in this range. So if we write this as an interval, this would be the interval from -1 to 1, including 1 and -1. The sign, cosine is essentially the same way. There isn't a whole lot of difference between x and y here. We have the smaller number on top, the bigger number on bottom. So again, this could be as small as -1 and as big as 1. It can't, since the bottom is bigger than the top, since we're dividing by a bigger number, we can't get something bigger than 1. So the cosine is still in this interval here. The tangent is going to be y divided by x, but if we think about what can y and x be, well, literally anything that we want. You could pick any point in the plane. So if there's no restrictions on what y and x can be, that means that I can make any fraction I want. This has no restrictions. And that means that what real numbers, what interval can we find these values in? Well, anywhere from -infinity to to infinity. So the range of the tangent function is all real numbers, whereas the range of sine and cosine is only going to be from -1 to 1. The cosecant is going to be the reciprocal of the sine, so it's going to be r divided by y. So now if we think about this, r is always bigger than y. So if I take a bigger number divided by a smaller number, that means that I have to get a number that's bigger than 1. So the cosecant of theta is always going to be greater than or equal to 1. It could be the case that we have negative numbers, though. Y could be negative, in which case this also means that we could have the other situation where the cosecant of theta could be less than or equal to -1. So one way to think about this is either the cosecant is really big and it's bigger than 1, or cosecant is really negative and it's less than -1. So if we think about all the possible values, we could have any number, any negative number up to -1. Or we could have any number 1 or bigger. And we would write this down using the union. So we have all of the small numbers, all of the negative numbers that are less than or equal to -1, or all of the positive numbers that are bigger than 1. The secant plays the same game, since we have r on the top and x on the bottom, and x and y can essentially be anything, but we always know that r is going to be bigger than x. So again, the secant could be bigger than 1 or less than -1. So again, it's the same range. We could have all the negative numbers up to -1, or we could get the positive numbers that are at least as big as 1. And then the last thing is the cotangent. So the cotangent of x divided by y, cotangent of an angle is going to be x divided by y. X can be anything, y can be anything, so cotangent of theta has no restrictions. So that means that this cotangent could be any number between infinity and -infinity. There's no restrictions. So let's take a quick peek at some potential trig functions, and let's see if they're real or possible or not. So could it be the case that sine of theta is equal to 1/2? Well, sine of theta is going to be y over r. R needs to be bigger than y. Sure, this seems possible. X could be 1 and r could be 2. That is certainly possible. So I'll give this a blue tick. That is certainly possible. Could the cosine of theta be equal to 2? And again, when we think about this, 2 is kind of the same as the fraction 2 over 1, but this isn't going to be possible, right? Because cosine is x divided by r, and r needs to be bigger than x. So this cosine 2 is in fact not possible. So we'll use a red X there. Could tangent be equal to -19? Well, tangent, which is x divided by y, x can be anything, y can be anything. There's no restrictions. Tangent can certainly be -19. Cosecant, can that be -1/3? Well, it could be negative. So any one of these trig functions could be positive or negative. That doesn't tell us anything. The 1/3, cosecant, is the reciprocal of sine, which is going to be r divided by y. R needs to be bigger than y. It doesn't look like it. This one is not possible. The cosecant, which we just set up here, has to be either less than -1 or bigger than 1, and that's right in between, so it doesn't work. The secant being equal to -3, that fits in our interval up here. The secant can certainly be equal to -3. That works. And then the cotangent being equal to 0, well, again, the cotangent can be literally any number, so that is certainly possible. So 4 of these were possible, 2 of these were impossible, and we can just check the ranges that are possible in here to see whether or not they could exist. So the last couple of things that I want to look at would be if you're given one trig function, can we figure out the rest? If we know the angle, absolutely, but can we figure out an angle just from knowing one trig function? And the way I'm going to do this, I'm going to draw a picture, and this is the way that I would encourage anyone who's trying to do these. Just draw a picture, and it makes it a lot easier. So we are told that our angle is in quadrant 1. So we're up here in quadrant 1, the upper right hand corner. And sine of theta, whatever theta is, I don't know if it looks like this, I don't know if it's like that, I don't know if it's like this, is going to be 2/5. So, well, we know that sine of theta is going to be y divided by r, and this is going to be 2/5. So one thing I could do is I could find where y is equal to 2 and where r is equal to 5. So r is going to be the length of our r is going to be the distance from the origin to this mysterious point out here. We know we can say that y is equal to 2, but we don't know x. So we know that this distance is 5, and this point up here is going to be x comma 2, but we don't know x. We can figure out x though, because we have a right triangle. So we know that x squared plus y squared, y I'm just going to use 2, is equal to 5 squared. So solving for x, x squared, 5 squared is 25, 2 squared is 21, sorry, 2 squared is 4, 25 minus 4 is 21, so x is the square root of 21. So we can write that in. Cool. So now that we know what x, y, and r happen to be, we can plug them in. So we can say that the sine of theta is going to be y divided by r. We were already told what that was. It's 2/5. Cosine of theta is going to be y divided by, it's going to be x divided by r. So square root of 21 over 5. And then the tangent of theta is going to be y divided by x. So this is going to be 2 divided by the square root of 21. Typically, they want us to rationalize our denominators. So multiply the top and the bottom by 21, by the square root of 21 to get 2 root 21 over 21, and that's as simple as we can make it. The cosecant, again, this is pretty straightforward. It's just going to be the reciprocal. The secant is going to be the reciprocal of this. So this will be 5 over root 21. But again, we want to rationalize the denominator, so we'll multiply the top and the bottom by square root of 21 to get 5 root 21 over 21. And then the cotangent, I'll take the original fraction that we took, take its reciprocal to get root 21 over 2. And there we have it. All 6 trig functions we found by using this. And I will talk a little bit more about this exact problem in the next video, why I could use 2 for y and 5 for r.